Let us have a look at few examples of discrete time Fourier series. In this example, we have a discrete time signal x of n, which is an impulse function, an impulse at n equals to 0, which is repeated after every 4 samples for n equals to 4, n equals to 8, n equals to 12, and so on. From the definition of period, we understand that x of n plus capital N equals to x of n. If this relation is satisfied, the period is referred to as capital N. For this particular function, we have x of n plus 4 equals to xn for all values of n. Thus, we can infer that the period n is equal to 4. Since the period n is equal to 4, we can refer that the fundamental frequency omega 0 is 2 pi by n, which can be 2 pi by 4, which can be evaluated 2 pi by 2. From the discrete time Fourier series of our discrete time signal x of n, we would get coefficients ck. So the range of k is from 0 to 3. So how we get this coefficient ck is, we perform the inner product on x of n and e raised to j k omega 0 n, these two functions, where omega 0 is again the fundamental frequency that we have calculated here. The expression for the inner product of x of n and e raised to j k omega 0 n can be found to be ck equals to x0 e raised to minus j k pi by 2 into 0 plus x1 e raised to minus j k pi by 2 into 1 plus x2 e raised to minus j k pi by 2 into 2 plus x3 into e raised to minus j k pi by 2 into 3. We can note that we have replaced the values of n in xn and e raised to minus j k omega 0 n from 0 to 3. That would be one period. Since we know that the value of x0 is 1 and all other values x1, x2 and x3 are 0, we replace these values in this expression of ck. We finally get that ck is 1 into e raised to minus j k pi by 2 into 0, which will be e raised to 0, and thus ck is calculated to be 1 for all values of k. Since k varies from k equals to 1 to k equals to n minus 1, that is 3, we have ck equals to 1 for 0 to 3. Since we have calculated the value of the coefficient ck for all values of k from 0 to 3, we can plot them in the following manner. For all values of k 0, 1, 2 and 3, the value of ck is 1. This graph can also be interpreted as the discrete time Fourier series coefficients of the signal for various values of omega. These values of omega are the component frequencies, and the component frequencies are 0, omega 0, 2 omega 0 and 3 omega 0, where omega 0 was calculated as the fundamental frequency 2 pi by 4 or pi by 2 in the first slide.